storing and organizing data elements in memory. I hope I'm audible to all of you. Okay. So it is a way of storing and organizing data elements in memory. Okay. So what it includes, it not only includes memory representation of elements. It misconception of like data structure is like how the values are being stored in memory. That is certainly part of the definition of data structure, but it is not only that. It also includes how those elements are related to each other. The relationship amongst those data elements is also part of definition of data structure. And that relationship or those relationships among the data elements of data structure are represented in the form of operations on elements. Okay. So अगर हम बात करें कि कंप्लीट डेफिनेशन क्या होगी डेटा स्ट्रक्चर की फ्रॉम इम्प्लीमेंटेशन पॉइंट ऑफ व्यू फर्स्ट इट इंक्लूड्स द मेमोरी रिप्रेजेंटेशन हाउ द वैल्यूज आर गोइंग टू स्टोर्ड इन मेमोरी सेकंड इट इंक्लूड्स द लिस्ट ऑफ ऑपरेशंस which are actually going to represent the relationship present in the elements among the elements of the data structure.
Because my audio नहीं है.
The definition of data structure includes the way they will be storing values in memory. Second, the allowed operations on those elements. And third, how those operations are going to be performed. Okay, their implementation. You must have heard another term, abstract data type. Okay. Abstract data type is first two, memory representation and operations. In abstract data type, we only mention input, output, and operation name. Data structures also includes implementation of those operations. And algorithm, as we all know, are like it is sequence of instructions to be followed to complete or execute particular operation or task. So we won't go into much details. So we will begin with arrays. And like we won't begin much into arrays, as we know, like all of you are familiar with arrays. So arrays are collection of items of same data type, and like they occupy contiguous memory location. This is what we know. Okay. So like this is the pictorial representation of array. So नहीं आ रही हेलो आ रही रिकॉर्डिंग ठीक. These are the elements of array, and as we all know, like every element will have an index. Indexing will begin from 0. And like since these elements are stored in contiguous memory locations, so if the address of first element, suppose it is 100. Okay. And assuming that integers are occupying 4 bytes, so address of second element would be 104. Third element would be 108 and so on. Okay. And the name of array, actually it stores the address of first element, beginning of the array. Okay. So the most common data structure that we confront is list, or we can say ordered list. So what is list? It is a sequence of elements. Okay. And we specify sequence because it is not only a set, the order matters. That is a particular sequence of elements. Necessarily, elements are supposed to be of same data type. Okay. And general operations are searching, insertion, and deletion. So by elements of same data type, what do we mean? Not only those built-in data types like integers, characters, integers, characters, or floats. Like suppose we talk about your attendance sheet. It includes your step ID, roll number, and name. So what we can do to store a particular record We can have three different variables for say ID, roll number, and name. But if you want to refer the whole information using one variable name, we can use a structure. We can define a structure, okay, or a class. Okay, having these three components, say ID, roll number, and name. And then that attendance sheet is a list. Okay. And individual element of the list is not only an integer or string or some floating value. Individual element is that one record. It can be represented by a structure variable. So to implement such list, we can have an array of structures. Okay. So ordered list is a sequence of elements of same data type. Data type may be built-in basic data types, or it may be some structure or class. So most common operations are searching, insertion, and deletion. But this list may be implemented like in two very distinctive ways. One is array implementation and another is linked implementation. Like we all are familiar with this. Okay. So if we talk about array implementation of list, so first we will discuss about how logically this is done. So elements of list are stored in a one-dimensional array. The first element is at index 0 and the nth element is at index n minus 1. Obviously, like these are the elements of the list. And like for convenience, we will be taking list of integers or values, numbers. So first element will be stored at index 0. Next element will be stored at the next index. And last nth element will be stored at index n minus 1. Okay. So if an element is at index x, its next element will be stored at index x plus 1, and its previous element is to be stored at index x minus 1. And in addition to this storage, we also need to maintain an integer variable n, which represents the total number of elements present in the list. So why do we need to maintain this variable n? Sorry. Computations को limit करने के लिए. Anybody else? Like we have stored the elements in 1D array. Why do we need to maintain this total number of elements? Okay. So we do maintain this total number of elements because since array is static allocation, like we will be discussing about pros and cons of static allocation. Since array is static allocation, so we need to declare an array of sufficiently large size. Suppose like we are working on a list and we assume that at 8 megs it may have 100 elements. So we need to declare the area of size 100. But at any point of time, like we may not reach 100 elements. Like we may have only 40 to 50 elements on average in the list. So we need to like whenever we are using array implementation, we need to think about worst case, like what may be the maximum number of elements we can store. Okay, we might be required to. So since it is a static allocation, we need to give a fixed size. Second, like we will assign values to some of the indexes of some of the cells and what the remaining cells will contain. Not necessarily zero, it may be garbage, it will be garbage values. Okay. And like if you store only these 5 values and if you print element at index 5, it won't give any error, it will print some value. Okay, that will be a garbage value. Okay. But how would we come to know that particular value which is being displayed? Whether it is part of the list or it is some garbage value. Like by chance, अगर fifth index पे जो garbage value है वो 120 है या -120. तो अगर हमने fifth index का element print किया, garbage है या list का part है, कैसे पता चलेगा? क्योंकि list भी numbers की. That is why we need to maintain कि लिस्ट में कितने एलिमेंट्स, n नंबर ऑफ एलिमेंट्स है, तो इंडेक्स 0 से इंडेक्स n-1 तक we will consider the list. ठीक है, that is why we need to maintain, like while we are implementing a list using array, we need to maintain number of elements. Okay, then on the upcoming slides we will be discussing about insertion operation. Whenever we will insert an element to the list in array implementation, we will increase the value of n by 1. Got it? And whenever we will delete an element from the list, we will decrement the value of n by 1. Okay. So that is why we need to maintain the count of elements in the list or in array representation of list. So these are the algorithms for searching operations. We won't dig in much. Like I hope you are familiar with linear search and binary search. Like we will also be looking at the implementation of linear search. So these algorithms are written in pseudocode notations, like your faculties or you might, like the text you are referring might have some other notations for writing algorithms. So understanding the logic is our primary concern. So we will look at linear search. How do we perform linear search? Do you have any idea? How do we perform linear search? Okay. So linear search is what our intuitive approach is. Like if I will give you a list of names which is not sorted, alphabetically sorted names, I will give you a list of names which is not sorted, and I will ask you like find Aman in this list. So what you will do? अपना intuitive approach क्या है? We will begin from the first name and we will scroll down until we find Aman. Okay, this will be our approach. And this approach is linear search. So suppose so this is an array with 5 elements, and if we want to search for 7, what we will do in linear search, we will compare 7 with the first element. It is not equal to 7, we will move ahead. Then we will compare 7 with the second element until we get an equal value. Okay. And once we get an equal value, we will display our answer. So what should be the output of searching operation? What do we expect is the output when we are searching for an element? Position, index. Okay. So in this case, we will print 7 is present at index 3 or 7 is present at 4th position in the list. If you want to print index, we can directly print index. If you want to print the position of the element, we can print index plus 1. Okay. What if the element to be searched is not present in the list or not present in the array? When would we come to know that the element we are searching for is not present in the array? So we started comparing from the first element. We move ahead, and when we compare with the last element, and that last element is also not equal to the element to be searched. Okay. Then we come to know that the element we are searching for is not present in the list. Again, in such case, that n number of elements in the list is also required. So, look at this algorithm. This is linear search algorithm. Array, number of elements, and elements to be searched is to be provided as argument. Okay. Array A, number of elements in the list is n, and element to be searched is x. Okay. Since these algorithms are written in pseudocode notations, and like I want to make a point of it, in pseudocode notations, in arrays, we assume that indexes are from 1 to n. If the size of array is n, in programming, the indexes will be from 0 to n-1, but in pseudocode notations, the indexes are assumed from 1 to n. Okay. So first element would be at index 1, last element would be at index n, and we will be comparing in sequence. So at the first iteration, we will be comparing the element to be searched with A1, first element. And if it is equal to the element to be searched, we will return that index. Okay. And this we will do for all the elements. Like if it is not equal, the loop will go ahead with second iteration. So once we will find with an equal element, the corresponding index will be returned, and return we all like it will exit from the function. And what does this return 0 means? This is okay, like the index to be the index I where the element is present, we want to return that. This return 0 has some like specific significance. Good. So like that case that we have discussed, like the element to be searched if that element is not present in the list. This loop will complete, this loop will terminate, and followed by it will be followed by return 0. So if this algorithm returns 0, it signifies that element is not present in the list. If it is present, it will return the corresponding index. So return 0 will work in case of algorithms in pseudocode notation. But in programming, you do have index 0. In that case, you are supposed to return -1 to show that element is not present. Okay. Binary search is only applicable on sorted lists. Like the elements are supposed to be arranged in either increasing or decreasing order. Only in that case we can apply binary search. And in binary search, what we do you have any idea? Suppose this list is sorted. Suppose if we want to search for 50. Okay. So in binary search, first it will compare the element with the middle element. Okay. Since it is sorted, it is like it will leverage that information. So first it will compare with the middle element. And if it is equal to the element to be searched, we go, we are ready with the result. We only need to print the index. And if the element to be searched is less than the given element, like element present in the middle, then we will search in the first half, like elements present before the middle element. And if the element to be searched is greater than the middle element, then we will search in the second half, like since the list is sorted. Okay. So how we will search in first half or second half, like once we have compared with the middle element, then we will have one decision. Like if we haven't found the element, we will search either in the first half or in the second half. Suppose we are supposed to search in first half since we are searching for 15. How we will search in first half? Again by applying binary search. Okay. Again by applying binary search, again we will compare it with the middle element. Okay. And once we will find an equal element, we will return the index. Got it? So, which is more advantageous, like linear search or binary search? Binary. But we need to have a sorted array in case of application of binary. Okay. So will it be okay if we sort the list first and then apply binary? So keep in mind थोड़ा सा complexity terminology मैं use कर रहा हूँ. If you talk about linear search, the complexity would be order of n. Why order of n? In worst case, we may require n comparisons. Like suppose we are searching for an element which is present at the last position, or we are searching for an element which is not present in the list. In that case, we require n comparisons. Okay. If we apply binary search, in worst case, we will be required to use log n comparisons. Like base would be 2. Why this is so? We are dividing the list in half after every comparison. So whether we are supposed to search in first half or second half after one comparison, the size of the remaining list is going to be half. Half, 1 by 4, 1 by 8, 1 by 16, until there is only one element left in this. So ultimately, number of comparisons required in worst case would be log n base 2. And certainly log n is smaller than n. That's why binary search is more appropriate, like if we talk about computing time. But when there is like prerequisite, the list is supposed to be sorted, and any sorting algorithm will take at least n log n. Okay. And this is going to be larger than n. But in general, like when we talk about list, the most frequent operation is searching. Like insertions would be there, deletions would be there, but searching would be most frequent operation. So even if we are required to sort the list once and then perform 100 search operations, in overall effect, binary search would become better than linear search. 100 times order of n से better है कि एक one time n log n sort कर लो और remaining 100 time log n से कर लो. ठीक है? That is why binary search is superior than linear search. तो linear search का कोड हम देखते हैं. आप लोगों ने कोड तो किया होगा linear search, like कोई difficult task नहीं है. Let us discuss about, let us have a look at the code of linear search. डिस्प्ले नहीं हो रहा है. वहां से स्क्रीन शेयर किया था कि पीपीटी शेयर किया था? पीपीटी शेयर किया होगा शायद. हाँ, पीपीटी को डिलीट नहीं करना. So this is code for linear search. This is the function for linear search which will require array, and n is the element to be searched. We are assuming that we have fixed number of elements, that is 5. Okay, so we are comparing the n with each index element at each index, and once we will find a match, we will display the position as index plus 1, and we will make 10 0, like we will change the value of 10. This is like a flag variable which is initialized with -1. So if we found a match, we will change the value, otherwise it will remain -1. So after completion of this loop, if the value of 10 remains -1, it means we haven't found a match, then it will represent the element is not present in the list. So this will be the main function. We we are only supposed to call the linear search by providing the name of array and the element to be searched. Okay. Then we will discuss about insertion and deletion operations. So insertion of an element in array implementation of a list. So we will be discussing about insertion at the particular position, like not necessarily at the end. We won't be discussing about append operation only. So like we keep the elements sorted, and these are indexes. And like we are assuming we have taken an array of sufficiently large size. So we have empty cells. Okay. So what will be the value of n here? 7. We have 7 elements. Okay. Suppose we want to insert 27. And like if the list is not sorted, we will give the position. So we want to insert 27 at 4th position. Okay. That means index 3. So if the name of array is A and if we assign A of 3 is equal to 27. So will this work? क्या प्रॉब्लम है? Fourth position पे 27 आ गया, but it will override 29. So we will lose that information. And what we are supposed to do then? We need to shift elements to the right. Like जिस position पे हमें insert करना है, उस position से लेके आगे के सारे elements को हमें we are supposed to shift those elements towards right. Okay? अब towards right shift करने में ध्यान रखिए कि आप ऐसे कॉपी मत कीजिए. ठीक है? You should begin shifting right from the end. Why this is so? हाँ, अगर हमने ये कॉपी करना चालू किया, यही एलिमेंट सारे प्लेसेस पे कॉपी होगा. 29 यहाँ पे कॉपी होगा, फिर 29 आगे कॉपी होगा. We are supposed to shift right from the end. ठीक है? इसलिए शिफ्ट इंसर्शन वाला जो एल्गोरिथम है वो लास्ट एलिमेंट से पोजीशन तक हमें जाना है. एंड शिफ्टिंग राइट मींस आई इंडेक्स पे जो एलिमेंट है उसको i+1 इंडेक्स पे स्टोर करना. ठीक है? तो ये शिफ्टिंग राइट इस तरीके से आप शिफ्ट करोगे तो यहाँ पे 56 होगा, यहाँ पे 49 होगा, यहाँ पे 35 होगा, यहाँ पे 29 होगा और यहाँ पे तो 29 है ही. इसके बाद यू विल राइट a of 3 is equal to 27. तो यहाँ पे 27 ओवरराइट हो जाएगा. This will be the insertion operation in array implementation of this. ठीक है? Again, once we will insert an element, we will increment the value of n by 1. Okay? That is what we need to do. N equal to n plus 1. So again, if we talk about the complexity of insertion operation, again it is going to be order of n. Why this is so? If we want to append an element, like if we are inserting element at the last position, the complexity would be 1. सीधा आपको कॉपी करना है लास्ट इंडेक्स पे जाके क्योंकि n का वैल्यू तो है आपके पास. But if you are inserting it like somewhere at the beginning, okay, then the order would be n. Like फर्स्ट पोजीशन पे इंसर्ट करना है तो n एलिमेंट्स को आपको राइट शिफ्ट करना पड़ेगा. ठीक है? The number of right shift would be n, so the complexity would be order of n. ठीक है? Similarly, in case of deletion, like कोई particular position का element अगर हमें delete करना है, तो डिलीशन के केस में दो तरीके से आपको टास्क मिल सकते हैं. एक तो लाइक the position is given, like suppose we want to delete the fourth element. Okay. So what we are supposed to do, like since this is a static allocation, we cannot erase the values. We cannot erase this 27 from here. We can only overwrite. तो ये जो एलिमेंट हमें डिलीट करना है, I don't want to see this element after the performance of deletion element. What we will be doing, we will be shifting left. ठीक है, और शिफ्टिंग लेफ्ट जो है आपको यहीं से स्टार्ट करना है. उसको इंक्रीजिंग ऑर्डर में शिफ्टिंग लेफ्ट करना है आपको. तो ए ऑफ आई इंडेक्स पे जो एलिमेंट है उसको i-1 इंडेक्स पे स्टोर करना है. और उससे क्या होगा, अब ध्यान से समझो ये n का सिग्निफिकेंस क्या है. यहाँ पे भी n का वैल्यू 7 है, 7 एलिमेंट्स हैं. ठीक है, 7 है सिंस इंडेक्सेस आर बिगिनिंग, लास्ट एलिमेंट जो है इंडेक्स 6 पे. अब अगर मुझे 27 डिलीट करना था तो मैंने क्या किया, 35 यहाँ कॉपी किया, 49 यहाँ कॉपी किया, 56 यहाँ कॉपी किया. ठीक है, लेकिन ये 56 इरेज नहीं हुआ है. लाइक इट विल प्रिंट एलिमेंट एट इंडेक्स 6, अगेन इट विल प्रिंट 56. ठीक है, so once we will delete an element, we will make decrement the value of n by 1. अब मेरा n का वैल्यू 6 है, तो I will print from index 0 to index 6 minus 1. That is why maintaining this value of n is mandatory, like in array implementation of this. We will share the code, like most of you have already implemented these operations, but we will share the code. The code is ready with us. But like I wanted to quickly begin with discussing about linked implementation. So there are few disadvantages in using array implementation or array representation of list. One is static allocation. Okay, so we have seen what is the disadvantage of static allocation. Like we need to allocate memory at the compile time. We cannot allocate memory at the runtime. We cannot increase or decrease memory at the runtime. Suppose we are considering the worst case. In worst case, we may require 100 elements to be stored, and if we declare the array of size 100, and on average, at a time, if we are maintaining only 50 elements, the remaining 50 cells is wastage of memory. If we declare an array of 50 elements only, like looking at the average case or best case, what would we do if we require to insert an element beyond the size? We cannot insert an, if we declare the size 50, we cannot insert 50 first element in the list. That is another disadvantage of array implementation. And most problematic is this complexity of insertion and deletion operation. We have seen that like the complexity of insertion operation is order of n. Like we may require shifting n elements if the insertion is at the beginning. Similarly, in case of deletion, if the deletion is supposed to be performed from the beginning, again we are required to n elements. So again, the complexity of deletion operation in array implementation is order of n. This is also problematic. Like generally, if the size of list is like this 5, 7, 10, it is okay. But actually, in practical situations, the list would be of size in thousands of elements. In that case, it will require like a significant computing time. And another disadvantage is like contiguous memory requirement. So, अगर हम suppose कीजिए student का record पूरा है, like a record of a particular student may require hundreds of bytes, one student, ठीक है? और ऐसे मान लीजिए thousands of students का record store कर रहे हैं university. Now this list will be requiring a huge size of memory, like in KBs. So it is also possible कि वो अपने KB का जो requirement है वो contiguous allocation मेमोरी फ्री नहीं है। जिन लोगों ने ओएस स्टडी किया है, तो अगर मेमोरी का रिप्रेजेंटेशन देखा होगा तो वो प्रोसेसेस को है ना ब्लॉक्स में मेमोरी एलोकेट होता है। इन दिस, जब जैसा चंक अवेलेबल मिलता है वैसा चंक रिक्वायरमेंट के हिसाब से एलोकेट हो जाता है। वो भी अलग अलग पॉलिसीज होती हैं मेमोरी एलोकेशन के लिए। तो सपोज कीजिए मुझे एक बहुत लार्ज एरे की रिक्वायरमेंट है, जिसके लिए मुझे 500 केबी का रिक्वायरमेंट है, लेकिन यहाँ पे मेरे पास 3 चंक्स हैं, 100, 200 and 400 kbs. In all, I do have 700 kbs available, but you cannot allocate the memory, like the OS cannot allocate the memory for that particular array, क्योंकि उसको तो contiguous चाहिए. So these are the disadvantages with array implementation of list. And like we will discuss briefly how linked list implementation will overcome all these disadvantages. Okay. So first, in linked list, we do have dynamic memory allocation. So now, in case of linked list, we will be having dynamic memory allocation, and that too for the only element to be inserted or stored. तो मेमोरी डायनेमिकली एलोकेट होगा, वो भी जब भी कोई एलिमेंट इंसर्ट करना होगा तो केवल एक एलिमेंट के लिए एलोकेट होगा। ठीक है, तो वो वाला जो डिसएडवांटेज है कि पहले से बहुत सारा मेमोरी एलोकेट कर दिया और वो यूज नहीं हो रहा है, ऐसा नहीं है। जितना एलोकेट होगा वो 100% यूटिलाइजेशन होगा लिंक्ड रिप्रेजेंटेशन। सेकंड, सिंस जितने एलिमेंट स्टोर हो रहे हैं हर एलिमेंट के लिए रन टाइम पे मेमोरी एलोकेट हो रहा है, तो ना तो मेमोरी का वेस्टेज है, ना ही कंटीन्यूअस मेमोरी की रिक्वायरमेंट है। तो लिंक लिस्ट में हम डिस्कस करेंगे कि डिफरेंट एलिमेंट्स में बी स्टोर्ड एट डिफरेंट लोकेशंस, वो कंटीन्यूअस मेमोरी की रिक्वायरमेंट नहीं है लिंक्ड इम्प्लीमेंटेशन। तो यहाँ भी मेमोरी एलोकेट हो सकता है, ये वाले खाली ब्लॉक में भी मेमोरी एलोकेट हो सकता है, ऊपर भी हो सकता है, क्योंकि एक इंडिविजुअल एलिमेंट को तो बहुत कम मेमोरी लगने वाला है। ये एक लिंक लिस्ट का एडवांटेज है। और प्राइमरी एडवांटेज इज कॉम्प्लेक्सिटी ऑफ इंसर्शन एंड डिलीशन ऑपरेशन। Once we will discuss about insertion and deletion operation on list, linked list, we will get to know how like this is far better as compared to insertion and deletion operation on array elements. ठीक है, और कॉम्प्लेक्सिटी का मीनिंग क्या है? कॉम्प्लेक्सिटी का मीनिंग ये नहीं है कि हमें प्रोग्राम लिखने में कितना कॉम्प्लेक्स लगे। ठीक है, कॉम्प्लेक्सिटी का मीनिंग है एग्जीक्यूशन टाइम, जितना कम होगा उतना कम कॉम्प्लेक्सिटी उतना ही बेटर। ठीक है, तो लिंक लिस्ट में हमें क्या करना है? What we will do in linked representation, like since the linearity, like you might have come across linear and non-linear data structures. Linear data structure जिसमें elements के बीच में एक linear relationship होता है, एक particular sequence होता है, previous next relationship होता है। So linearity in array is implicitly maintained. How? क्योंकि वो contiguous memory location पे है। तो अगर एक element, one element is present in index 3, we can state कि इसका previous element जो है it is at index 2, इसका next element जो है it is at index 4। या अगर एक element integers का अगर array है and if the element is present at memory address 1000, तो we can say कि इसका previous element जो है वो 996 एड्रेस पे है, इसका next element जो है 1004 एड्रेस पे। That linearity is implicitly maintained in array because contiguous memory allocation. But since in linked list every element may be stored at different location, पहले एलिमेंट को मेमोरी एलोकेट किया रन टाइम पे, मान लीजिए उसका एड्रेस 100 है, सेकंड एलिमेंट का एड्रेस हो सकता है डायरेक्टली 200 हो, थर्ड एलिमेंट का एड्रेस हो सकता है 50। तो एलोकेट तो हम करते जाएंगे, एलिमेंट स्टोर करते जाएंगे, बाद में पता कैसे चलेगा कौन सा एलिमेंट किसका प्रीवियस है किसका नेक्स्ट है? एरे में तो प्रॉब्लम ही नहीं था, कंटीन्यूअस मेमोरी लोकेशन था। So in addition to storing element, we also need to store the address of next element, which we will call link to the next node. Okay? That is why we are required to store address as well with the element in case of linked list. क्योंकि अलग अलग एड्रेस पे होंगे, कोई सीक्वेंस नहीं है, तो एलिमेंट्स का सीक्वेंस हमें पता चले, इसलिए we will be storing link address of next element graphically, which will be represented by array. ठीक है? सेकेंड, array में array का स्टार्टिंग कहाँ से है? That we can get to know by the name of array. Like since name of array stores the base address, the starting address or address of first element. So if the name of array is A will have the address of A0. Okay. By like stating name of array, we can get where the array is beginning from. Again, in case of linked list, ऐसा कुछ है नहीं हमारे पास. So what we will be doing, we will be maintaining a separate pointer variable start, in which we will store the address of first node. तो स्टार्ट से हमें पता चलेगा कि पहला नोड कहाँ स्टोर्ड है इन केस ऑफ लिंक रिप्रेजेंटेशन. तो एलिमेंट एंड एड्रेस ऑफ नेक्स्ट एलिमेंट, ये इस यूनिट को we will term as node. Graphically link will be represented by arrow, और लास्ट एलिमेंट का कोई नेक्स्ट एलिमेंट नहीं होगा तो we will store none in the link field. ठीक है? So in case of linked list, we will be briefly discussing about these three operations: searching, insertion, and deletion. So what we need to do, first we need to understand the logic behind the operation. Then we can go through the code for those operations. So suppose we need to search for an element in case of linked list. Okay. So first we are going to use these two notations in our algorithms. Suppose address of a node is I. So data I will refer to the data field, the value, and link I will refer to the link field, the address of next. Okay. So what we will do when we search for an element, so we need to have the start pointer. The start pointer is supposed to be provided as argument, and we also need the element to be searched. Suppose we are searching for 15. Okay. So how can we search? अभी एरे में क्या होता था, कंटिन्यूअस मेमोरी लोकेशन पे होते थे, इंडेक्सेस होते थे, तो इंडेक्स +1 करके हम नेक्स्ट पे पहुंच जाते थे. लेकिन यहाँ पे एड्रेस में +1 करके हम नेक्स्ट नोड पे नहीं पहुंचेंगे, क्योंकि दे मे बी स्टोर्ड एट वेरी फार डिफरेंट लोकेशंस. ठीक है, तो प्लस करके नहीं होगा. व्हाट वी कैन डू, वी कैन बिगिन फ्रॉम हियर. So what we will do, we will begin from a temporary pointer variable and will assign start pointer to it, like temporary equal to start. Okay. Then we will compare with its data value, and if it is equal to the element to be searched, we do have the address of element. And if it is not equal to the element to be searched, what we will do? We are supposed to move this pointer to the next node. Okay. तो अभी तो स्टार्ट पॉइंटर से टेम्परेरी वेरिएबल में, टेम्परेरी पॉइंटर में फर्स्ट नोड का एड्रेस आ गया. अगर इसके डेटा एलिमेंट के इक्वल नहीं है, then how would we come to know कि सेकंड नोड कहाँ पे है? सेकंड नोड का एड्रेस चाहिए. वो कहाँ से मिलेगा? फर्स्ट नोड की लिंक फील्ड से. What we will write? T equal to link of t is referring to this field. ये एक्चुअली क्या है, ये सेकंड नोड का एड्रेस है, ठीक है। आपके पॉइंटर में सेकंड नोड का एड्रेस आ जाएगा। अब इसकी डेटा फील्ड से कंपेयर कर लीजिए और सेम प्रोसेस रिपीट करते जाइए जब तक कि आपको एलिमेंट मिल नहीं जाता है। जैसे मिल जाएगा तो आप पॉइंटर टी जो है उसको डिस्प्ले कर दीजिए। अब क्या होगा, अगर जो एलिमेंट आप सर्च कर रहे हैं वो प्रेजेंट नहीं है, तो लास्ट में आपका टी पॉइंटर यहाँ पे आएगा, ठीक है। सपोज वी आर सर्चिंग फॉर 45, फिर आपने इसकी डेटा फील्ड 30 को कंपेयर किया 45 से, वो भी इक्वल नहीं है। उसके बाद हम क्या कर रहे हैं, टी इक्वल टू लिंक टी कर रहे हैं, टी इक्वल टू लिंक टी करेंगे, लेकिन सिंस इसका कोई नेक्स्ट नोड नहीं है, इसकी लिंक फील्ड में नल है, तो टी इक्वल टू लिंक टी करने पे टी का वैल्यू क्या आ जाएगा, इट विल बिकम नल। So once the value of t becomes null, it is signifying that the element which we are searching for is not present in the list. ठीक है? So this is what this algorithm works around. जब तक डेटा फील्ड में एलिमेंट नहीं मिल जाता या फिर नल नहीं हो जाता। अब जब ये लूप टर्मिनेट होगा तो ये एंड कंडीशन के साथ है, तो अगर डेटा फील्ड में इक्वल टू ई हो जाएगा तो ये फॉल्स हो जाएगा, या फिर टेम्प नल हो जाएगा तो ये फॉल्स हो जाएगा, ठीक है। तो अगर इस लूप से बाहर आ रहे हैं और डेटा फील्ड ई के इक्वल होने की वजह से अगर बाहर आ रहा है तो 10 का वैल्यू नल नहीं होगा, उस केस में इज प्रेजेंट एट द एड्रेस 10, और 10 इक्वल टू नल होने की वजह से बाहर आ रहा है, द लूप इज टर्मिनेटिंग व्हेन 10 इज गेटिंग इक्वल टू नल, वो अभी हमने डिस्कस किया कि इट इज सिग्निफाइंग दैट एलिमेंट इज नॉट प्रेजेंट इन द लिस्ट, ठीक है। ये सर्चिंग ऑपरेशन है। मेन एडवांटेज ऑफ लिंक्ड implementation over array implementation we will get to know from this insertion and deletion operations, ठीक है। तो अगर किसी पर्टिकुलर पोजीशन पे हमें इंसर्ट करना होता है एलिमेंट, तो लेकिन array we need to shift the elements towards right, but linked list में हम क्या करेंगे, first look at the logic, then we will look at the algorithm. सपोज कीजिए कि मुझे 20 के बाद में नेक्स्ट में कोई एलिमेंट इंसर्ट करना है, सपोज कीजिए 20 के बाद मुझे 25 इंसर्ट करना है, ठीक है। Like there may be different cases, we want to insert at the beginning, we want to append at the end, we want to insert in between by specifying the position, या मैं कोई स्पेसिफिक एलिमेंट स्पेसिफाई कर रहा हूँ उसके नेक्स्ट में मुझे इंसर्ट करना, ओके। तो व्हाट आई विल डू, जब भी नया एलिमेंट अगर हमें इंसर्ट करना है तो उस एलिमेंट के लिए मेमोरी एलोकेट करना पड़ेगा, उसके लिए नोड क्रिएट करना पड़ेगा। What I am assuming कि we have a function get node I available with us which will create a node and its address will be stored in variable I. Get node I यहाँ पे क्या सिग्निफाई कर रहा है कि एक नोड क्रिएट करेगा और उस नोड का एड्रेस जो है वेरिएबल I में स्टोर हो जाएगा, ठीक है। Then what I will do, suppose I want to insert 25, इसकी डेटा फील्ड में I will store 25। कैसे स्टोर करूंगा, डेटा फील्ड को कैसे रिफर कर रहा हूं मैं, डेटा I से, क्लियर। अब ये 20 के नेक्स्ट में इंसर्ट होना है, दैट मींस ये 20 और 15 के इन बिटवीन इंसर्ट होना है। तो अब मुझे अकॉर्डिंगली लिंक्स जो है वो चेंज करना पड़ेगा, ठीक है। तो लिंक्स कैसे चेंज करना पड़ेगी, ध्यान से समझिएगा। 25 की लिंक फील्ड में मुझे 15 वाले नोड का एड्रेस स्टोर करना पड़ेगा, ठीक है। ये यहाँ से डिस्कनेक्ट करना पड़ेगा और 20 की नेक्स्ट वाली फील्ड में, लिंक फील्ड में मुझे 25 वाले नोड का एड्रेस स्टोर करना पड़ेगा, ठीक है। तो ये डिस्कनेक्ट करने के लिए कुछ और नहीं करना है, मैं नया एड्रेस ओवरराइट कर दूंगा, ठीक है। तो अब मुझे दो लिंक फील्ड चेंज करना है, तो जो नया नोड क्रिएट किया इसके लिंक फील्ड में 15 वाले नोड का एड्रेस डालना है, स्टोर करना है। व्हाट डू आई रिक्वायर, एड्रेस ऑफ नोड जिसका डेटा वैल्यू 15 है, एक्चुअली जो 20 का नेक्स्ट वाला नोड है, ठीक है। और इसका एड्रेस तो आई में होगा, लेकिन सिंस 20 वाले नोड की लिंक फील्ड चेंज करना है तो 20 वाले नोड का एड्रेस भी चाहिए। ठीक है, तो 20 वाले नोड का एड्रेस कैसे मिलेगा? वो जो सर्च ऑपरेशन हमने यूज किया था, वैसे हम 20 सर्च करते करते आगे बढ़ेंगे तो 20 वाले नोड का एड्रेस मिल जाएगा। तो 20 वाले नोड का एड्रेस मिल गया, इसकी लिंक फील्ड से 15 वाले नोड का एड्रेस मिल जाएगा। ठीक है, फिर जो आई वाला नोड है उसकी लिंक फील्ड में सपोज कीजिए 20 वाले नोड का एड्रेस टी मिला। व्हाट आई विल राइट, लिंक ऑफ आई इज इक्वल टू लिंक ऑफ टी। तो लिंक ऑफ टी मतलब ये वैल्यू क्या है? इस नोड का एड्रेस है, तो यही हमें यहाँ पे स्टोर करना है। ठीक है, एंड देन आई विल राइट लिंक ऑफ टी इक्वल्स टू आई, क्योंकि यहाँ पे आप मुझे इस नोड का एड्रेस स्टोर करना है विच इज आई। तो यहाँ पे मुझे क्या एडवांटेज समझ में आ रहा है इंसर्शन में? मुझे एलिमेंट्स को शिफ्ट नहीं करना पड़ा। ठीक है, what I am doing, I am changing only two link pairs. So this is the advantage of linked representation over array representation. तो ये एल्गोरिथम आप गो थ्रू कीजिए। ठीक है, तो नोड क्रिएट किया, नोड की डेटा फील्ड में एलिमेंट स्टोर कर दिया, फिर ये सर्च किया हमने 20 वाला नोड, तो टेंथ जो है उसमें 20 वाले नोड का एड्रेस आ गया। फिर लिंक ऑफ आई इक्वल टू लिंक ऑफ टी, लिंक ऑफ टी इक्वल टू आई। ठीक है, similarly we can look at deletion algorithms. We will share the code as well. मैं आपको इसका corresponding code भी बता देता हूँ। सारे operations like we cannot discuss in the given time duration. बस ये कोड दिख रहा है कि बंद कर दो। फाइल इनसे शेयर कर दीजिएगा सेशन के बारे में। पीपीटी डालनी, पीपीटी और ये फाइल भी डाल दूंगा, है मेरी पेन ड्राइव में है। पिलर की डालनी। अच्छा, okay, so is the code visible to all of you, like people sitting at the end? Is this visible? Yes or no? दिख रहा है वंशिका? तो like what you can do, you can use a structure or class node define करने के लिए। So here we are using class. तो node में क्या रखेंगे हम? दो फील्ड होती है, डेटा फील्ड होती है, एक लिंक फील्ड होता है जिसमें नेक्स्ट नोड का एड्रेस होता है। ठीक है, अब एड्रेस स्टोर करना है तो पॉइंटर वेरिएबल चाहिए। ठीक है, और यहाँ पे ध्यान से देखो आप कि ये पॉइंटर वेरिएबल का डेटा टाइप क्या है? नोड। नोड क्यों है? क्योंकि पॉइंटर वेरिएबल से अगर आप फैमिलियर हैं तो अगर इंटीजर का एड्रेस स्टोर करना होता है तो हमें इंटीजर पॉइंटर लगता है, कैरेक्टर का एड्रेस स्टोर करना होता है तो कैरेक्टर पॉइंटर लगता है। तो लिंक फील्ड इज स्टोरिंग एड्रेस ऑफ नेक्स्ट नोड, नॉट ओनली नेक्स्ट एलिमेंट। तो लिंक फील्ड जो है एक्चुअली उसमें नोड का एड्रेस है, इसलिए लिंक फील्ड को स्टोर करने के लिए जो पॉइंटर है उसका डेटा टाइप भी नोड होगा। ठीक है, अब ये एल्गोरिथम है which will insert the node at the beginning। सबसे पहले आप नोड इंसर्ट करेंगे तो क्या करेंगे? स्टार्ट पॉइंटर है आपके पास, नया नोड क्रिएट करेंगे, उसकी डेटा फील्ड में वैल्यू स्टोर करेंगे। अब इसकी लिंक फील्ड में जो पहले फर्स्ट नोड था उसका एड्रेस चाहिए। ठीक है, इसकी लिंक फील्ड में पहले फर्स्ट नोड का एड्रेस स्टार्ट पॉइंटर में था, तो स्टार्ट पॉइंटर असाइन कर देंगे। ठीक है, अब यहाँ पे टास्क कंप्लीट नहीं होता क्योंकि स्टार्ट पॉइंटर बाय डेफिनेशन फर्स्ट नोड का एड्रेस होना चाहिए स्टार्ट पॉइंटर में। सो अभी तो स्टार्ट पॉइंटर में 10 वाले नोड का एड्रेस है जो कि फर्स्ट नोड नहीं रहेगा आफ्टर इंसर्शन। व्हाट वी नीड टू डू, दिस कैन बी डन वेरी सिंपली। ठीक है, तो ये जो इम्प्लीमेंटेशन है, दिस इज फॉर इंसर्शन ऑफ अ नोड एट द बिगिनिंग। तो यहाँ पे देखो ये न्यू नोड जो है, इट विल, दिस इज कंस्ट्रक्टर, इट विल क्रिएट, इट विल allocate मेमोरी फॉर अ नोड। ठीक है, और न्यू से कर रहे हैं तो न्यू से क्यों कर रहे हैं, सिंपली ऑब्जेक्ट क्रिएट क्यों नहीं किए, न्यू से कर रहे हैं तो डायनेमिकली है। ठीक है, डायनेमिकली वो ब्लॉक एलोकेट होगा और उस ब्लॉक का एड्रेस जो है वो न्यू नोड पॉइंटर में आ जाएगा। तो न्यू ऑपरेटर क्या करता है, जो भी आप स्पेसिफाई करते हो उसके उसको जितनी मेमोरी रिक्वायरमेंट है उतना ब्लॉक एलोकेट करता है और उसका एड्रेस रिटर्न करता है। अब एड्रेस रिटर्न कर रहा है तो उसको पॉइंटर में स्टोर करना पड़ेगा। तो यहाँ पे जो हमने वेरिएबल आई लिया है, एक्चुअली न्यू नोड विल स्टोर दैट एड्रेस, एड्रेस ऑफ न्यूली क्रिएटेड। ठीक है, फिर हम उसकी डेटा फील्ड में डेटा स्टोर कर देंगे, है ना, डेटा आई इक्वल टू वैल्यू करके। So since we are referring to the element by pointer variable, that's why we are using arrow. क्योंकि पॉइंटर वेरिएबल से अगर क्लास या स्ट्रक्चर के एलिमेंट को रिफर करना होता है तो we will be using arrow. अब देखो, न्यू नोड नेक्स्ट इक्वल टू, ये हेड रेफरेंस मतलब फर्स्ट नोड का एड्रेस, तो हम वही कर रहे हैं, लिंक आई इक्वल टू एस, स्टार्टिंग पॉइंटर हम असाइन कर रहे हैं। तो न्यू नोड नेक्स्ट इक्वल टू फर्स्ट नोड का एड्रेस, देन एस इक्वल टू आई जो लिखा है, क्योंकि न्यूली इंसर्टेड नोड जो है आफ्टर इंसर्शन दिस विल बिकम द फर्स्ट नोड ऑफ द लिस्ट, इसलिए स्टार्ट पॉइंटर में या यहाँ के केस में जो हेड रेफरेंस वेरिएबल है उसमें नए नोड का एड्रेस होना चाहिए। ये जो स्टेप्स मैंने यहाँ बताए हैं सेम उसके लिए फंक्शन है। एंड दिस कोड कंटेन्स लाइक all these three different cases: inserting at the beginning, inserting at the end, and inserting it somewhere in between. ठीक है, तो this is what we will be sharing with you. So we will take a pause here. uh, इन लोगों का कुछ फिलर एक्टिविटी है, in case if you have any doubt like whatever we have discussed so far, we can, I will try to answer. ये कोड फाइल शेयर होगा, इसको जाके शाम को एग्जीक्यूट करके जरूर देखें। ठीक है, और एक एक स्टेटमेंट पढ़ के समझने की कोशिश करना कि क्या है। नहीं आता है तो कल हम डिस्कस कर सकते हैं। यस, कंपनी का नाम बोल, मैं यहाँ पे जो स्टार्टिंग पॉइंटर लिया है ना हमने एल्गोरिथम में, ये बोलने वाला वही स्टार्टिंग पॉइंट, मेरे को शॉर्ट पे ही अच्छा तो बोले कि बोलने में शॉर्ट पे इसको बाद में नहीं इसमें होगा पता नहीं मैं वहां से कुछ बोलता हूँ। पीपीटी का नाम क्या है, पीपीटी का नाम क्या, पीपीटी का नाम क्या जी, इससे पहले बड़ा कर दे वो फटाफट पहले समझा देंगे सभी हमारे नीट। So everyone, we will begin with the pillars now. On time, please come in.
Hello everyone. So let's take a break, okay? So that overloading na ho jaye thoda. And here's a fun game for you guys. Cheer up a little bit, okay? Fine. We are gonna do DSA. We are going to do more DSA, but like little bit. Okay. So here's the thing. You guys have to guess who is there on the screen, looking at the photo hint that will be given. There will be a part of the photo, and you have to see and you have to guess, okay? It's an individual thing, there's no teams or something, but be competitive, okay?
To get something improved are the most important personal improvement.
So like easy first.
You have to raise your hand and then we'll pick a person who will answer that. No. Who will first? So, which movie? Okay.
The character name.
Okay, and then got the point.
Yeah, that was correct.
Clap for your friends.
Okay, so one more easy peasy and super trendy one for you guys.
Okay, always.
Yeah, Advani and Siddharth.
Yes.
Yeah.
So you can clap for this thing.
The next one is a little Netflixy. Don't prompt the answer, just raise your hand.
Okay, always.
Yeah.
Always.
Wednesday,
You have to raise your hands.
Wednesday, and
One more point for always.
Yeah. Okay, so then
So let me make you remember for grammar.
guys, please don't prompt the answers, okay?
Okay. Maybe got the point. Pretty I can clap for.
Okay, so the next one is a little tricky. So let's see.
Okay. That's not the point. It was kind of obvious, I guess. Mona Lisa. You got the point. Okay, so we're in the lead right now. Okay, yeah. Okay.
Yeah.
Daniel got the point. So now it's tied between Daniel and Ovid. Ovid again.
Johnny Depp from Paris.
Ovid in the leader.
No, what's the character name?
Captain Jack.
Okay, Daniel got the point. Hell is the lead right now. You have to.
Gia.
Yeah.
Yeah.
You got the point.
So the Bollywood skins are being taken up by girls only or what?
Character name.
Yes. Gia. Okay.
Or- Okay, the actor's name. Who is?
Yeah, Gia said it first, I guess.
Yeah.
Earlier. Yeah.
Yeah, got the point. But still, till now, please get on to and okay, so the way in middle, you can tap on. Then you will get something, what you want. You get your help.
Okay, so that's it from my side.
Okay, the checks that we have circulated among you all, it is for like writing something about DSC, like the feedback, or you can write about like the lead or any lead, any person, anything that you want. That's just the feedback kind of thing.
Pen.
You guys don't have any pen. Okay, we'll circulate a pen. You can write on it after this. Thank you. School. Yeah. Okay, so we will begin with the next data structure that we will be considering is stack. Stack and queues, that is what we will be discussing in this second part of the session. So stack is again, it is a list with some specific property which stands LIFO list. Last in, first out list. What actually stack is? It is a list where insertion and deletion both operations are performed from only one end, which is called top. Okay. So we will directly be jumping to the array implementation of stack. And then we will be discussing about implementation of this insertion and deletion operations on array implementation of a stack. Okay. So we can store the stack as one-dimensional array since a stack is a list with one property which is called default. So it will be stored similar to a list in a one-dimensional array. So the bottommost element of the stack will be stored at index 0. Okay. The elements are supposed to be stored from bottom to top, not from top to bottom. So the bottommost element of the stack will be stored at index 0, and the element above it will be stored at index 1, and so on. In that case, if an element is present at index p, element above it will be stored at index p plus 1, and element beneath it will be stored at index p minus 1. Again, we need to maintain a variable which is named top, which will be storing index of the top element. Okay. And let's, if we talk about implementation, we will initialize this variable top with -1. Why -1? Like if we initialize top with 0, and we do have element index 0 here, it will signify that there is one element present at index 0. We need to initialize top with -1, and value of top being -1 is will represent that the stack is empty. Okay. So we will talk about insertion and deletion operations in case of array. So in case of array, the insertion operation is also called push operation, and the deletion operation is also called pop operation. So how this insertion operation will be performed? Since we are assuming array implementation, so we are assuming that we have sufficiently large array available with us. So the value of variable top is 4. And suppose we want to store an element. Okay. So like if we look at this graphical perception of stack, if an element is supposed to be inserted, it will be above the top element. Okay. So as per the definition of memory representation, अगर कोई element index p के above है, तो it will be stored at index p plus 1. So in array representation, if I want to insert or put f above e, I have to store f in the next index of e, like whatever is the top element. What we will be doing, we will be incrementing value of top by 1. Okay. Then it will move to the next index, and then, like suppose the name of array is A, R, R. Then we will store the element which is supposed to be inserted in that new value of top. It is doing two jobs in one go. One, since f is supposed to be stored in the next index, it is moving to the next index, and after the insertion, f will become the top element, so value of top is supposed to be incremented by 1. जैसे हमने लिस्ट के array representation में n का वैल्यू इंसर्शन में इंक्रीमेंट किया, तो ऑटोमेटिकली टॉप का वैल्यू इंक्रीमेंट होगा. ठीक है. And similarly, in case of deletion, suppose we want to delete. So in case of mistake, we do not have any choice in case of deletion. If we want to delete this particular element, or we want to delete element from some specific position. In case of mistake, only the element which is present at the top will be deleted. So in case of deletion operation, what we are supposed to do? We need to delete this. And since we are talking about array implementation, again I will say we cannot erase this value. We cannot erase f from index 5. So what we can do, and what we are supposed to do, we are supposed to only decrement the value of top by 1. So now the value of top will become 4. Okay. So we cannot erase f from index 5. So that's why we will maintain top, so that like if we are required to go through the elements of the stack, we know the foundation कि अगर value जो top का value है, so elements of the stacks will be from 0 to top minus 1 only. ठीक. So these are the algorithms. So suppose we have like allocated memory for 10 elements. Last index पे top पहुंच गया insertion करते कर. We cannot insert more elements. If the value of top is like last element or last index, then we need to display a message that stack is full, we cannot insert any more. Otherwise, we will increment the value of top by 1, and in that particular index, we will be storing the value. Similarly, in case of deletion, अगर stack empty है, we cannot delete. We have already discussed that value of top being -1 is signifying that the stack is empty. Okay, so if the top is -1, and again, like as I have already told you, in pseudocode notations, indexes are from 1 to n, and in programming, it is 0 to n minus 1. That's why I have written these comments. So these algorithms are in pseudocode notation. तो अगर यहाँ पे n लिख रहा हूँ, तो प्रोग्राम में आपको n minus 1 लिखना होगा. यहाँ पे 0 है, तो प्रोग्राम में -1 लिखना होगा. So if top is -1 in programming, then it will signify that stack is empty. Otherwise, top equal to top -1 will suffice. Generally, this statement is used like we do store the value to be deleted in some variable, because that value to be deleted might be required for displaying purpose or might be required from other calculations. ठीक है, जैसे आपने applications of stacks कभी स्टडी किया होगा, जिसमें हम expressions evaluate जो एलिमेंट हम पॉप करेंगे, we require those values for operation. So generally, whatever element is deleted, we do store that element in some variable, because that value might be required in further operations. So this is the array implementation of stack. How can we implement this using class. Just give me a minute. Okay. बस वही क्या ये फिर से शेयर नहीं हो रहा है रिवर में। क्या देखिए बात करना Actually, I'm going to spend. Okay. So we will declare a class stack. We will create a class stack, and like basically what we require in a stack class, the array in which we will be storing the elements and the top variable. Like these two variables are like have been taken as element of this stack class, but this is not mandatory. Like this may be temporary variables in the function definitions. But what is mandatory? The array in which we will be storing the stack and the top. Is there any issue? So this is the constructor, default constructor, and which will begin the value of top with 0. Like in this implementation, they have begun with the top equal to 0. What we have discussed during the algorithm, we will be beginning with top equal to -1. Why they had begun with top equal to 0? Because while inserting, they are first assigning the element, then incrementing the value of top. We have incremented the value of top first, then assigned the value. So this will work in effect like in similar fashion. The element we will compare top equal to top with the max size, that is size of array. And if it is equal to the size of array, we will display a message that a stack is full. Okay. And otherwise, we will enter the element to be inserted, and we will increment the value of top and will insert the element. Similarly, if we talk about pop function, so here like initial value of top is 0, which is also signifying that stack is empty. So stack being empty will be signified by top equal to 0. In this case, we will print stack is empty. Otherwise, like only decrementing the value of top by 1 will suffice. And as I have already told you, like it might be required to display the value which is like being deleted. Here in the definition, we are displaying the element being deleted. Again, display, what it will display? Display function will display the elements of the stack. So we will begin with top -1 index and we'll go up to the 0 index. That is why value of top is also required to check like from where we should begin. And like we can write a menu-driven program by giving choices to the users for performing any of these three operations and like one exit option. So this is how a state can be implemented using a class. Okay. Then if we talk about linked implementation of flag, it's pretty simple. The top element would be like the node containing the top element of the stack will be the first node of the linked list. And like the element beneath it will be the next node. Element beneath to that element will be next node. And in this way, the bottommost element would be the last node. Okay, and its null link will be its link would be null. And similar to start pointer, we will maintain a top pointer which will store the address of top element. Okay. So if we talk about insertion or push operation in case of a stack, linked implementation of a stack. Okay. So where it will be inserted? At the beginning or at the end or somewhere in between? Given the linked implementation of a stack, if we want to insert an element or push an element onto a stack, okay. Suppose if this is top pointer, suppose if we want to insert an element L. So after insertion, F will become the top element. And like what we have discussed about linked implementation of stack, the top element should be the first element of the linked implementation. So we will insert at the beginning. We will create a node, assign the value. Okay. And like we all know what links are supposed to be changed. This is what we have already discussed in case of linked list. Okay. So in case of array implementation, insertion or push operation is like inserting at the beginning. Okay. What about pop operation? Like if you want to delete an element from a state from the linked implementation of a state. Okay. So where it should delete, like the first element is supposed to be deleted, the last element is supposed to be deleted, or we can delete any element from in between. First one, because the element to be deleted is to be top element. We can only delete top element. So to delete the first element, what should we do? It will be the case of deletion where we do deletion from the beginning or we do delete the first one. It is pretty simple. In case of deletion from the beginning, we only need to change this, the top variable or start variable, which is storing the address of first node. उसमें केवल second node का address हमें store करना है, ठीक है? वो कहाँ से मिलेगा? उसी की link field से मिल जाएगा. Actually, we are supposed to write top equal to link of top. ठीक है? And since, like pay attention, since we will be storing memory dynamically using new operator. So we can also release the memory when we are deleting some element, which is also an advantage. जो नोड डिलीट हो रहा है उसकी मेमोरी को हम फ्री कर सकते हैं, रिलीज कर सकते हैं यूजिंग फ्री ऑपरेशन. Free function is available. Okay. So to release the memory, we need to have the address of that node. जैसे like node containing value e, if I want to delete this node, and after deletion, तो deletion के दो step होंगे. First we need to disconnect that node from the list. That we can do by assigning top equal to link of top, so that top will have the address of second node, which eventually going to be the first node after deletion. Okay. After disconnecting the node from the list, we need to release the memory using free function. ठीक है. ये memory release करना है जिस नोड की, तो उस नोड का एड्रेस चाहिए. अगर मैंने ये कर दिया टॉप इक्वल टू लिंक टॉप, तो टॉप में तो सेकंड नोड का एड्रेस आ गया, लेकिन फर्स्ट नोड का एड्रेस वी विल लूज दिस इंफॉर्मेशन. ठीक है. अगर मुझे इसको फ्री करना है तो इसका एड्रेस चाहिए. What I will do, I will use some temporary variable, उसको टॉप असाइन कर दूंगा. Then I will use this address to release the memory. ठीक है. What I will do in case of deletion, I will use some temporary variable to store top. ये क्यों जरूरी है? So that I can free the memory. Otherwise, top equal to link top will be sufficient to disconnect the node from the list. Next is queue. Queue is again, it is a list, a specific case of list with the property which is called LIFO, last in. No, FIFO, first in, first out. So in case of list, we will be, in case of queue, we will be having two different ends. From one end, the insertions will be performed. That end will be called rear end. And from another end, the deletions will be performed, which is called front end. So in effect, the element which is going to be inserted first will be deleted first. Okay. So again, in case of queue, we can insert an element from rear end. But in case of deletion, we do not have any choice which element is supposed to be deleted. Only the element present at the front end, first position, will be deleted. Okay. So again, we will look at the array implementation of queue, which is pretty simple. Again, we will store it in a 1D array, front element at the front position being stored at index 0. And now we will maintain two counter variables. One is front and another is rear. Rear variable will store the index of rear element. And there are two different ways in which we can deal with queues. Okay, like, and this is an example of linear queue. Like when you will go through the text or web, there you will find two different ways in which queues are dealt with. So one is this, where front will store the index of front element. And second, which is like I am taking as an example, where front stores the index of front element -1. ठीक है. और इससे क्या होता है, वो जो इंसर्शन डिलीशन ऑपरेशन होता है उसके इम्प्लीमेंटेशन में स्लाइट डिफरेंस आता है. So if we talk about insertion जो है वो rear end से होगा. If you want to insert an element F, it will be stored at index 5. Okay, what we will do? And since the rear variable is supposed to store the index of rear element, तो हम rear equal to rear plus 1 करेंगे और उस index पे नया element जो insert करना है वो store कर देंगे, assign कर देंगे. ठीक है. अब ऐसा करते करते since it is array implementation, static allocation, अगर array का size full हो जाता है, हम last index पे पहुंच जाते हैं. After that, if there is any requirement of insertion operation, we cannot insert. In such case, we need to display this message queue is full. Otherwise, if queue is not full, we'll increment the value of rear by 1, and in that index we will be storing the value. Similarly, in case of deletion, what we are supposed to do? Deletion will be from the front end. Okay. So in case of stack, जब हमने delete किया था, तो what we have done? We have decremented the value of top equal to top -1. But here we need to be cautious. Like when we will delete, value of front will be also be incrementing by 1. Front equal to front plus 1 होगा, front equal to front -1 नहीं होगा. ठीक है? And again, like the value which is supposed to be deleted, we may store that value in some variable for display purpose or some other calculation purpose. And look at this condition, like when will the queue be empty? And it is, the condition is rear equal to front. And it is not front equal to -1 or rear equal to -1. Okay. So rear equal to -1 will definitely signify that the queue is empty. Okay. But जैसे ये केस है, इस केस में फ्रंट इज -1 जो डेफिनेशन हमने ली है, तो फ्रंट बीइंग -1 डज नॉट सिग्निफाई दैट क्यू इज एम्प्टी. ठीक है, rear equal to -1 does signify that queue is empty, but that is not the only case. Actually queue will be empty when front will become equal to rear. जैसे ये वाला केस है, इस केस में जो डेफिनेशन हमने लिया है क्यू का, या जो हमने डेफिनेशन लिया है फ्रंट और रेयर की वैल्यू का, तो इस केस में फ्रंट का वैल्यू हमारा -1 है और रेयर का वैल्यू है 4. ठीक है, सो इफ वी डिलीट a, वैल्यू ऑफ फ्रंट विल बिकम 0. If we delete a, value of front will become 0. If we keep on deleting b, c and d, once we will delete value of once we delete d, value of front will become 3. Okay, like after every division we increment the value of front, so once we delete d, the value of front will become 3. And what if we will delete e as, जब हम e delete करेंगे, according to the implementation we will increment the value of front by 1. Now the value of front will become 4 and the value of the rear was 4. When front becomes equal to rear, it signifies that the queue is empty. Okay, rear being -1 is definitely, in that case queue will be empty, but that will not be the only case. These are the implementations we have already gone through. And we talk about linked implementation of queue. Again, the front element will be the first node, rear element will be the last node. Okay. Here we can maintain 2 pointers representing the front element and the rear element. But maintaining rear pointer is not necessary. Like if we do have front pointer, by traversing through, जब तक कि null link नहीं आ जाता, we can get the address of rear element. But for convenience, we can also maintain address of rear element. अब यहाँ पे इंसर्शन और डिलीशन की बात करेंगे, तो इंसर्शन रेयर एंड से होता है, तो इट विल बी इंसर्शन फ्रॉम द एंड, और डिलीशन फ्रंट एंड से होता है, तो इट विल बी डिलीशन फ्रॉम द फ्रंट. ओके, तो डिलीशन फ्रॉम द एंड के केस में हमें क्या करना होता है, तो लास्ट नोड हमें डिलीट करना है. तो डिलीशन के केस में मैंने बताया कि आपको इसको डिस्कनेक्ट करना पड़ेगा. ठीक है, और डिस्कनेक्ट करने के बाद इसकी मेमोरी को हम रिलीज करेंगे. अब डिस्कनेक्ट करना है, तो लास्ट नोड डिलीट करने के लिए जब हम लास्ट नोड डिलीट करेंगे, तो जो सेकंड लास्ट नोड था, इट विल बिकम द लास्ट नोड ऑफ द लिस्ट और क्यू. ठीक है, तो इसके नेक्स्ट फील्ड में जो इसका पहले जो लास्ट नोड था उसका एड्रेस था, वो नहीं होना चाहिए. सिंस दिस हैज बिकम द लास्ट नोड, इसके नेक्स्ट फील्ड में या लिंक फील्ड में हमें नल स्टोर करना पड़ेगा. ठीक है, अब इसके लिंक फील्ड चेंज करना है, तो इसका एड्रेस चाहिए, वो हम ये लूप से मेंटेन करेंगे. Like since we are maintaining rear, ठीक है, deletion is insertion at the beginning. Insertion is deletion from the beginning and insertion is insertion at the end. So insertion at the end में हमें क्या करना है? नया नोड क्रिएट करना है, उसमें वैल्यू स्टोर करना है, और सिंस इंसर्शन एट द एंड है तो जो नया नोड क्रिएट होगा उसकी लिंक फील्ड में हमें नल स्टोर करना पड़ेगा, ठीक है। और ये जो पहले लेयर एलिमेंट था जिसकी लिंक फील्ड में नल था, आफ्टर इंसर्शन उसमें नए नोड का एड्रेस स्टोर करना पड़ेगा, और रेयर जो है रेयर पॉइंटर में लास्ट नोड का या रेयर नोड का एड्रेस होता है, तो इस नोड के प्लेस पे रेयर में हमें इस नोड का एड्रेस स्टोर करना है। तो हम क्या करेंगे, यहाँ पे एक नया नोड क्रिएट करेंगे, उसकी डेटा फील्ड में वैल्यू स्टोर करेंगे, सिंस एंड में इंसर्ट हो रहा है तो उसके लिंक फील्ड में नल कर देंगे, ठीक है। और अभी रेयर में इस नोड का एड्रेस है तो इसकी लिंक फील्ड में लिंक ऑफ रेयर इक्वल टू आई करेंगे तो इसकी लिंक फील्ड में न्यूली इंसर्टेड नोड का एड्रेस आ जाएगा, और लास्ट में रेयर पॉइंटर में रेयर एलिमेंट या लास्ट नोड का एड्रेस चाहिए तो वी विल असाइन रेयर इक्वल टू आई, एंड अगेन deletion will be deletion from front, so it will be implemented this way. तो क्यू का हम क्लास इंप्लीमेंटेशन अगर देखें, this is similar to the way we have discussed the implementation of stack. So again, it will have the array in which we will be storing the queue. Here we will be maintaining two different variables, rear and front. Then again, in the constructor, we will initialize these two values with 0. Insertion के case में the rear is already next size, that is size of array. Rear is already at the last index. We will display that queue is full or queue have reached the maximum. Otherwise, we will increment the value of rear by 1 and assign the newly inserted element. For deletion of element, what we have seen, when the queue will be empty, when the front will be equal to rear, the queue will be empty. Otherwise, we will be only incrementing the value of front. If we want to display the value of front element, we can do that. Or we can store this value to be deleted in some value. And look at this display function. It will display elements from front to rear. Okay. Now the front is not necessarily will be at 0. Like if there are 10 elements and if you delete 4 elements, front will be at 4. Your actual queue would be from front to rear only. Okay. So generally when we discuss about the implementation of queue, और जो कोड हम वेब पे देखते हैं, तो वहां पे क्या करते हैं, जब भी हम क्यू से एलिमेंट डिलीट करते हैं तो जो इनिशियल सेल एम्प्टी होता है, एम्प्टी तो नहीं होता है क्योंकि वैल्यू नहीं होती है, लेकिन लॉजिकली वो एम्प्टी होता है क्योंकि फ्रंट आगे बढ़ जाता है। जो कोड हमने देखा है जब हम वेब पे देखते हैं, ठीक है, तो सपोज हम डिलीट कर रहे हैं तो 10 विल बी डिलीटेड, ठीक है। तो जनरली जब वेब पे सर्च करते हैं तो जब हम डिलीशन ऑपरेशन करते हैं तो व्हाट दे डू कि इसको हटाने के लिए दे डू लेफ्ट शिफ्ट द एलिमेंट्स, रिमेनिंग एलिमेंट्स, ठीक है। तो इन एवरी डिलीशन दे डू लेफ्ट शिफ्ट। एक्चुअली लीनियर क्यू के केस में लाइक आई डू नॉट एग्री विद दिस इंप्लीमेंटेशन। अगर वो आगे का सेल एम्प्टी रहता है तो रहने दो, दैट इज एक्चुअली द डिसएडवांटेज ऑफ लीनियर क्यू, एंड दैट्स व्हाई वी डू स्टडी एंड यूज सर्कुलर क्यू एज वेल। तो अगर ऐसे हम राइट शिफ्ट करते जाएंगे तो लाइक वी डोंट रिक्वायर सर्कुलर क्यू, ठीक है। तो ये जो सारा कोड है एंड विद लाइक सम प्रॉब्लम स्टेटमेंट्स, आपसे कुछ स्टडी मटेरियल शेयर भी हुआ होगा, और ये कोड और वो प्रॉब्लम स्टेटमेंट्स आप ट्राई कीजिए यूजिंग this hard coding, go through this code. And like in tomorrow's session, we will be briefly discussing about STL first, and then we will be taking problems and their solutions using STL. Okay. So if you have any query, we can discuss. Otherwise, you can proceed on with your filler activity.
Okay, so hey everyone. Hello. Okay, so hello everyone. From your faces, I think you guys are a little bit tired, I think. Is it? I guess first we can stop the recording. So as Sir mentioned, for tomorrow's event, what we have planned is what our overall plan was. Firstly, I'll tell you that we thought let's go with DSA in a way with what you can implement or what you can use, the knowledge that you can use. We all are studying DSA in our academic, but apart from it, are we able to use it in our life? Like, are we able to use it actually? So that's why we tried to target lead code questions, and that was our main motive. But jumping on directly to the lead code questions wasn't a very, very wise decision to make. So firstly, this session was mainly hard coding related so that you understand the concept. So now once you're clear with the concept, we can move on with the solving question thing tomorrow. So tomorrow, the things that you learned today, the things that you implemented using class today, you'll be implementing those things using STL library, which is a C++ library, without writing this all this hard code. You will be directly calling the functions. Like you saw code for insertion. Now, what if I tell you you don't need to write entire code or entire function for it? You can simply do it by just calling a function. Wouldn't that be wonderful, or wouldn't that be very interesting? So actually, in real use, we use those functions. We don't write all these code every time we use. And I have seen this general perception that people have about C++ and Java is that they think this is an extensive language or where you have to write too much. Like whenever I talk to someone who is using Python, whenever I'm asking them कि भाई तुम C++ क्यों नहीं use करते हो? Why do you prefer Python more मतलब तो often I get the answer is कि इसमें सब चीजें बहुत simply हो जाती है या फिर एक लाइन में कोड हो जाता है या फिर दो लाइन में कोड हो जाता है तो ये बेटर लगता है हमें तो ये चीजें C++ में भी पॉसिबल है एंड ये चीजों की वजह से ही वो मतलब डेवलप कर रही है लैंग्वेज अभी भी तो इसमें STL है मेनली जो आपको अलाउ करेगा ये सब करने के लिए तो वही हम टारगेट करने वाले हैं कल के सेशन में हम आपके साथ अभी नोशन की पेज की लिंक शेयर करेंगे जहां पे ये सब जो हमने पढ़ाया है इसके नोट्स आपको अवेलेबल किए जाएंगे आई गेस वासु यू कैन शेयर इट इन द ग्रुप एज वेल विद देम सो इसके नोट्स भी हैं and also we are sharing one more notion link which is containing questions related to these topics that we discussed today and they are basic introductory questions you can go on with further with more questions also in future but for now if you are able to solve those questions I will assume that your concept is a bit clear if you are able to solve those questions we'll be covering some of those questions tomorrow in our event in our tomorrow's event and rest, if you guys face any issue or any trouble, you can still contact us and we'll try to help you out with those. Right. So with on this note, I would like to end the session with this. Should